Okay, as promised, we're moving on to thermal strain. All those cracks, this is why they're here. Now, while strain is often caused by applied loads, it can also happen due to thermal expansion. Remember, because strain is just a change in length. Now, this is why expansion joints have to be placed in long bridges, because it allows the bridge sections to stretch without crushing each other, and also without opening up horrible cracks when they get cold. You do not want a car to fall into some terrible ravine because you left a big gap so that they wouldn't touch each other on a hot day. Not a good thing here, not a good thing. So we have these expansion joints all along the bridge. It's also why if you look at a sidewalk, even when it's been newly poured, you'll see little grooves. And those little grooves are meant to be places for the sidewalk to fail. As it expands, it will crack along that groove, and that will give just enough space that the sidewalk can expand and contract, without destroying the larger sections. Now the equation is really simple, and it's related to our coefficient of thermal expansion, alpha. And it's simply your thermal strain, which is always normal strain, is going to be equal to alpha times delta T. Change of temperature times alpha. And therefore, if we wanted to, we could use this to calculate the total strain, which would simply be, the total normal strain would simply be our thermal strain plus the strain from the applied load. And this is extremely important. Do not forget that thermal strain exists. That will lead to huge failures in things you create if you don't think about that. Because it will cause extra stresses. Just like this strain is caused by normal stress, the thermal expansion will cause a stress. The thermal strain will cause a thermal stress, and you have to take that into account. Both things are going to be adding up to the situations you're looking at, and both can lead to terrible consequences if you're not careful. So remember, thermal strain caused by heat. Any change in temperature, whether positive or negative, will cause a thermal strain, and it's all related to the thermal coefficient of expansion. So, thanks for listening, and this is a short one, and next time we'll jump into some examples. Have a great day. Bye-bye.